Hello. How's it going? You're gonna hear a lot of ambient noise because my dog's barking upstairs and the washer and dryer are probably on. So whatever. But I wanted to kind of continue with what we were learning before. I think we stopped at the Bronsted-Lowry acids and bases, and strong acids and weak acids, strong bases and weak bases. So what we're going to do today is hopefully learn about the auto-ionization of water and calculating pH. So if you have your calculator, you're probably going to want that. And let's go. I'll put some questions up here, and then I'll give you some review questions to work through. I know you're probably wondering about grading. I think what I might do is count your homework as some points, and I may end up giving you guys some worksheets and stuff that you could do, that you could hand in the answers for points as well. Okay, so here we go. So beforehand, we had learned about the strong and weak acids, but we never really talked about water. And by the way, you'll like that I'm using the Melissa and Doug. This is Chloe's chalkboard that I'm using here. So, all right. So here we go. Water does kind of an interesting thing here. So water acts as what's called an amphoteric substance. Amphoteric meaning that it can act as an acid or a base. So what it does is one of these things, the H2O here or the H2O there, can be the proton donor, the other one can be the proton acceptor. And so if we imagine that an H plus is kind of shooting over to this water, and then you'll see that you're going to form H3O plus OH minus. And both of these guys over here are AQ. These are both liquids. Okay, so in our equilibrium discussion, you remembered our big K. And remember I was saying like there's going to be tons of these Ks. Well, this K is called KW. It's for the auto self ionization of water. Okay, and which means it's the self-ionization of water. It happens at a very, very low rate. Let's say 1 out of every 10 billion collisions or whatever, one of the waters might, knock an H over to another water, and but it's an equilibrium. So as fast as that occurs, these things are going to do the same exact thing. So then, so that's called the auto-ionization of water. And the KW of this is where I would ask you, hey, can anybody tell me what the K value of this reaction would be? But I'll answer my own question. This would be H3O plus times OH minus. We wouldn't put these two liquids in there because we don't put solids and liquids in equilibrium expressions. And so then what you'd end up with would be these two things multiplied by each other. And at 25 degrees, remember, temperature is the only thing that changes your equilibrium constant number. At 25 degrees, the number for KW is 1 times 10 to the negative 14th. Okay, that's a given. So that is a constant, will not change unless you change the temperature. So that's a really, really good thing to know. Okay, that water will auto-ionize and form this very, very low KW. Most of the substance in this equation is over here, but you're going to end up with 1 times 10 to the negative 14th as your value. So if I told you, oh, well, I have a solution over here, let's call it solution A, and solution A has an H3O plus concentration of 1 times 10 to the negative 8th, and I say this is at 25 degrees, can I solve for the OH minus? And the answer is yeah. All I would need to do is plug in Kw is 1 times 10 to the negative 14th. I'd plug in this for my H3O, and I would end up getting, an OH minus. You could probably do it in your head. It's 1 times 10 to the negative 6th, but the math behind this is going to be, so we're just going to use this up here. It's 1 times 10 to the negative 14th equals, and I told you your H3O is 1 times 10 to the negative 8th, 1 times 10 to the negative 8th times OH minus, and if you plug it into your calculator, OH minus is 1 times 10 to the negative 6th. Okay, so based on all this, I can then do maybe what you had learned last year. It's possible, but what we're going to do is we're going to start converting these things to powers and talk about the power of H, the power of OH right now. Okay, so here we go. All right. This idea of pH is the power of hydrogen, and the formula for pH is negative log of H3O plus. And I know I told you before, H3O plus and H plus are the same, so sometimes you'll also see pH equals negative log H plus. Okay, so same thing with the power of OH or the power of hydroxide. Usually you'd use that for bases. We will rarely use POH, but POH is negative log of hydroxide. And then I could do all the K1s and K, I could do these reactions, but let's just say, should probably memorize these equations as well. H plus times OH minus is 1 times 10 to the negative 14th, and pH plus POH equals 14. Okay. So these formulas we're going to use, I'd write them down just to make sure that you have them, and I'll show you a couple of examples of how you'd end up solving questions based on this with a strong acid, and then tomorrow we'll do the weak acids with pH. Okay, so I'm going to revert to this. I could tell you now also that sometimes people are going to get the H plus and want to know, sometimes you're going to get the H plus or the H3O plus and you're going to want to know the pH. Sometimes you're given the pH and you're going to want to know H3O or any of these. And it's just an inverse log business. So I know most of you are going to use your 89s for this, but I'll just show you real quick. If you are going to do, so remember before, like pH equals negative log of H3O plus. If I wanted to solve for H3O plus, I would, divide by -1, divide by -1. So I'd have negative pH equals log H3O plus. Usually these are log base 10. And then what you would do is you do 10 to either side. Those would cancel. And then you're done with 10 to the negative pH equals H3O plus. Same thing with POH. 10 to the negative POH equals the concentration of OH. Okay, so you want to get really good at using these formulas. Okay, so here we go. All right, let's say I give you solution B, and I say, oh, solution B has a concentration of hydroxide that is 2 times 10 to the negative fourth. Okay. So in this case, you might be able to guess that as long as, I mean, we'll assume that most of these things are at 25 degrees. So so what we're going to do is we're going to say, like, all right, OH equals 2 times 10 to the negative fourth. That's lower than 10 to the negative seventh. So, I'm sorry. What am I saying? That's greater than 10 to the negative seventh. So, at 25 degrees, you know this solution is going to be basic. If you have more OH than you have H3O. So this solution is going to be basic because that number, I mean, 10 to the negative fourth is still very small, but it's greater than 10 to the negative seventh. So therefore, this is going to be a basic solution because you know your H3O plus is going to be above 10 to the negative seventh. It's got to be a higher exponent there. So let's calculate it here. If I wanted to solve for H3O plus, pH, H plus, and POH. So all you need is one thing, and then you can learn all the other, you could calculate all the other four. Because that's how this works. So what we would do first is probably we could easily solve for H3O or H plus. They're the same thing. So I would do my 1 times 10 to the negative 14th equals H3O plus times OH minus, and know that I could solve for my H3O here. This would go there, and then H3O plus would be 5 times 10 to the negative 11th, I believe. So now, since you know that, you can then know your H3O and your H plus. So you'd say, all right, well, this is 5 times 10 to the negative 11th, 5 times 10 to the negative 11th, and you're good. Now, you're going to have to use a calculator here because unless you're amazing at logs, you're probably not going to be able to do this. I'm just going to erase this for a second here. Okay, so now we're going to go negative log of H3O is going to give us our pH. Negative log of H3O plus. So you'd go negative log 5 times 10 to the negative 11th, and that gets you 10.3. So now you'd say, okay, that's going to be 10.3 based on pH plus POH is going to give you 14. You could just plug in 10.3 and you'd know POH is 3.7. And then you just solved for everything. You got it all. So then what would I say about solution B? Well, I'd probably go back to what I know about pH and say, all right, well, if I know a pH is below 7, it's acidic. If it's above 7, it's basic. And if it's at 7, it's neutral. So water, pure water at 25 degrees is a pH of 7. It's neutral. So I'm going to give you a couple of these to practice with. I don't want to make this lesson too long because it's your first one, but I would expect you guys to take notes on this and, put it in your notebook. And as we get more of these and as I get better at them, I'll extend them a little bit longer. But hopefully this kind of makes sense. I'm going to do one more for you, and then I'll give you some to practice for homework. And like I said, still not 100% sure how I'm going to grade, but it'll probably be, some sort of worksheet that I make, and I'll just send it on Google Classroom based on the notes and stuff. So, all right. Okay, so let's say we got another container, solution C, and we know the pOH is 3.7. Okay, so, and I ask pH H3O plus OH minus, and I'm gonna keep putting H plus in there, even though I know H3O plus and OH, I'm sorry, H3O plus and H are the same thing. It's good to keep seeing this because they're so interchangeable. You'll see them on some test, and you just, it'll be second nature to you to I don't even know what the word is, equivocate H3O plus and H plus. So here we go. Right away, you should be able to tell me that my pH is 10.3. Did I make, this is the exact same numbers. Let me just change this up a little bit. All right, let's make it 6.9. Okay, so pH would be 7.1 because pH plus pOH is 14. H3O is, so I'm going to plug it in as it's 10 to the negative 7.1, but you're not going to have, that's not going to be your answer. You're going to go 10 to the negative 7.1, which gives you 7.94 times 10 to the negative 8th, which is also your H plus 7.94 times 10 to the negative 8th. And then you're going to go this times this. Laundry's done. This times this is 1 times 10 to the negative 14th. So you would just go 1 times 10 to the negative 14th divided by that. And that would give you 1.25 times 10 to the negative 7th. So, therefore, I always go by pH to tell me if it's acidic, basic, or neutral. This one is very, very slightly basic. It's a pH of 7.1. And then I would say we would then, and I'll just write this down. So the pH scale is like this. If you're a 7, it's neutral. This way is acid. This way is basic. Okay. So, good start. And I'll post this. And like I said, I'll put on some homework here. And miss you guys. See you very soon, hopefully. And hope you guys are all safe and healthy. All right. Bye-bye.